In this tutorial, I will be exploring concepts for how to manipulate lists and nested lists. This current definition shows the description of a two-dimensional XYZ grid. I can view the XYZ grid by using a Watch 3D component. Within the Watch 3D component, you can see a simple two-dimensional grid. After setting the definition to run automatically, as I begin to adjust the grid sliders, you can see how the grid is changing. I'm going to grab a normal watch component so I can see the actual data of the XYZ grid. You will notice that this is a single continuous list of points. Each point in the list corresponds to an item index. I can access a single point out of the entire list by using the getFromList component. Within the getFromList component, I will supply the list of XYZ points. I'm then going to use a number component to specify the index. To view the item I'm extracting, I'm going to use a watch component. After I connect the getFromList output into the watch component, I can see that I've pulled out a single item from the master list of points. By changing the index value, you can see that the watch component updates with a new point value. At this stage, I'm only working with a single list of points. It is also possible to slice a list up into multiple sublists. I'm going to search for the slice list component. The slice list component will create several nested lists by slicing up the master list. I'm first going to insert my XYZ grid list into the slice list component. To pull out a list of rows for each sublist, I can use one of my number sliders to slice it. I'm going to use a watch component so I can see my nested lists. When comparing the nested lists to the master list, you can see how the data has been sliced up into a series of sublists. In this case, each list of list corresponds to a single row out of the XYZ grid. We can use getFromList to pull out multiple items from each of the nested lists. I will use the list output as the input for the getFromList. I can then use a number component to specify the index. To view the result, I will pull out another watch component. In this case, you can see how specifying a single item index has allowed me to pull out that index from each of the nested lists. To visually see how this list extraction is working, I'm going to create some additional geometry around the extracted points. In this case, I'm going to create a circle curve geometry. I'm going to input my list of points in for the center of the circle. I now need to specify a radius for these circles. For this, I'm going to use a number component. I will test out the circles with a radius of 1. I'm now going to use a Watch 3D component so I can visualize these circles. This visualization clearly shows that I've pulled out the first item from every single row of points. If I change the index from my getFromList, you can see that I can cycle through different rows of points. If I increase the index to 2, you can see that I end up at the third row of points. It is important to note that Dynamo is a zero-based programming language, meaning that item 0 refers to the first item in the list, whereas item 2 would refer to the third item. If I want to flip the list nesting so I have rows of circles going in the opposite direction, I can use a tool called transpose in order to reverse the list nesting. If I type in transpose lists into the command line, I can pull out a new component. I'm going to input my sliced list output into the transpose lists. I'm then going to replace the list input of getFromList with the transpose lists. You will notice that your circles are now being created along the opposite direction of the grid. These core concepts of list manipulation are present in most Dynamo definitions.